continue the second property by the ear can distinguish between the different sounds. We started in the video number 1 in the sound pitch. Now we are going to continue by the sound intensity. What's meant by the sound intensity? It is the property by which the ear can distinguish between the strong and the weak sounds. And this sound which will make it strong or weak, it will be depend about the amount of the energy coming from the sound falling perpendicular in the unit area. If the amount of energy falling in the 1 unit area, big amount of the unit area which is surrounding this point in the 1 second, so it will have a high intensity. If it falls in the low amount area, it will be low intensity. Let's continue. The measuring unit of the sound intensity will be measured by the watts per meter square, and the measuring unit of the noise intensity will be measured by the decibel. The factors which affecting the sound intensity, it will be the distance between the sound source and the ear, the amplitude of the sound source, the area of the vibrating surface, and the density of the medium through which the sound travels, and the direction of the wind. Let's start by the first one, the distance between the sound source and the ear. We have here the distance between the sound source and ear. If you had an activity by making any sound source and increasing the distance far away from this source, we found when the distance increases by the double, the sound intensity decreases. So they have an inversely proportional relationship. Again, as the distance increases, the sound intensity decreases. And we calculated it in the rule or in the law, which is defined as the inverse square law of the sound. The inverse square law of the sound, it will be the intensity of the sound at the point varies inversely with the square of the distance between the point and the sound source. So the sound intensity equal or has a relation 1 over distance 2. So here, when the boy have a sound by this distance, we will have a low sound intensity. But this boy, the sound intensity increases more, and this sound intensity increases more and more because the distance decreases so much. And so, when we said the intensity of the sound increases 4 times when the distance between the sound source and the ear decreases to the half. Why? We will answer because the sound intensity is inversely proportional to the square of the distance between them. Again, why the sound intensity increases 4 times when the distance decreases to the half? Because the sound intensity has inversely proportional with the square of the distance. Let's continue. The amplitude and the sound source. The amplitude of the sound source is the sound intensity has a direct proportional with the square of the amplitude. As when you made this activity by using any ruler and you're going to make hidden to the ruler by your hand, of course the ruler going to be moved up and down and making sound. So there is when the amplitude, when the ruler make a maximum displacement, more sound intensity falls and more sound will be heard. And when the distance decreases, less intensity will be heard. Third one, the area of the vibrating surface. The area of the vibrating surface, it will be increases when the sound intensity increases. Like when we put a mobile phone inside this resonance box which is made of wood, and using the vibrational motion of the phone, we will hear the sound of the phone very clear. Why? Because the area increased, and so the sound intensity is going to be increased. And also, instead of putting a mobile phone, putting a tuning fork, it will be also increases the sound intensity. So when I'm asking you, the intensity of the sound increases when the sound source touches a resonance box due to increasing the surface area of the vibrating body. The density of the medium. We are going to make this activity by putting a clock in the air vacuum here. The clock, we're going to make a sound and cover it by a glass jar. We are going to start to pump out the air gradually, which means by pump out, getting out the air from the jar. What happens when the air gets out? The sound intensity decreases by decreasing the air molecules. And what happens if we put a carbon dioxide gas instead of the air, of course, we are going to hear the sound intensity increases again. And so when the density of the medium, such as a carbon dioxide gas, increases, the sound intensity increases. So sound intensity increases as the density increases of the medium, and so the sound will be travels increases. So there is a direct relationship between the sound intensity and its the density of the medium. Note, this is a very important note, the intensity of the sound on the top of the mountain is less than of the surface of the earth. The sound intensity of the carbon dioxide is higher than the air. Why? Because the density of the carbon dioxide more than the density of the air. So you will hear the sound of the clock very clear when we put carbon dioxide inside the glass jar. The wind direction, it is the last property which is the sound intensity affected. The sound intensity increases when the wind direction will be in the same direction of the sound wave propagation. Imagine when you call your friend or loud your voice, and it will be in the same direction of the wind, so the sound will be traveled clear and the sound intensity increases. But if you exist in the area in the opposite direction of the wind, your sound voices will be disappeared or will be not transferred clearly to your friend. So the sound intensity decreases when the wind direction in the opposite direction of the sound wave propagation. So there is a direct relationship. The third property is the sound quality. The sound quality, how can we distinguish between the sounds of different sources, such as the sound of the tuning fork or the sound of the guitar or the sound of the piano? Of course, each one of them has a different tone. This different tone will be complicated by a fundamental tone. Let's repeat it again. All the instruments or the musical instruments has a first fundamental tone, and this fundamental tone are complicated or can be associated with a harmonic tones, which is the tones different from one musical instrument to another. So the tuning fork produces a fundamental tone, while the violin or piano has a fundamental tone plus harmonic tone. So we call it a complicated tone. So we can classify the vibrating body producing two tones, fundamental and harmonic tones. Fundamental, it's a simple pure tone which is produced from the vibrating body, such as tuning fork. Harmonic tones, which are tones which are associated to the fundamental tone, which is the lower intensity and higher in pitch, to make the tones you hear it from the songs. Piano sounds differ to that from the violin, even if they have the same intensity and pitch. Why? Because the harmonic tones which are associated to the fundamental tone of the source will be higher in the pitch and lower in intensity. So we can define the sound equality as it is the property by which the ear can distinguish between the different sounds according to the nature of the sources, even they are equal in intensity and pitch. We can here classify the types of the sound waves according to their frequency. We have an audible sounds and non-audible sounds. The audible sounds, the sound which can be heard by the human ears, and we call it a sonic waves. Its frequency ranges from 20 to 2000 hertz or 20 kilohertz, and it can be heard by human ears only. Non-audible sounds like the infrasonic waves or ultrasonic waves. Infrasonic waves which are less than 20 hertz, and it can't be heard by the human ear, of course. And ultrasonic waves which have more than 20 kilohertz or 2000 hertz, and this is also cannot be heard by the human ears. These both infrasonic or ultrasonic waves can be heard by animals such as dogs, as the dogs hear the sound of the storm before the human, and also some fishes using these ultrasonic waves like the dolphins too can be communicated with each other. Of course, all of this cannot be heard by the human ear. The human ear, when I have a question, give reason. The human ear can hear sounds of frequencies ranges from 20 to 20 kilohertz. Why? Because the audible tones only can be heard by the ear. Some sounds can't be heard because the human ear affected only by the sound frequency from 20 to 20 kilohertz. Applications of the ultrasonic waves. The ultrasonic waves can be used in many fields, such as a medical field for breaking down the stones of the kidneys and uterus, maybe for the diagnosis of diseases in the prostate gland tumor or the malignant tumors. All of this, it will be used for the man to determine some diseases, or it can be used in the industrial field for the sterilization of the food or milk or the water, because these ultrasonic waves, it can have the ability to kill some types of bacteria and stop action of some viruses. Also, it can be used in the military fields for discovering the land mines. Now we are going to start our knowledge complete in several ways. By using the same gear, the sound produced will be sharper by increasing its, yes, of course, frequency. Some animals, such as dogs, dolphins, and some cats, can hear ultrasonic waves. The measuring unit of the sound intensity is watt per meter square, while the noise intensity measured by decibel. Thank you for watching this video. Please study this lesson very well and see you next video, inshallah.